This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 2 weeks. Thanks to our audience and the partners listed on our website for supporting the podcast. Welcome listeners to a new episode of Software Engineering Radio. This is the third one we record at JAU 2008 in Aarhus in Denmark. And this time we're going to talk about APIs, API designs, and general concerns when dealing with APIs. And our guest today is Jim Des Rivieres. I hope this is pronounced correctly.
Yes, very good.
Hi, Jim.
Hi, Marcus.
Well, before we talk about the topic, why don't you introduce yourself to our listeners briefly?
Currently, I work for IBM. I work with the Eclipse and Jazz teams, helping to get APIs in place. In some places, I've actually done some of the heavy lifting of actually defining the APIs. In other places, and sort of much more common, I've worked with the teams and helped them to form their APIs and maintain them and evolve them over the years.
Mm-hmm. So, well, obviously this discussion is about APIs. So why don't we start by kind of defining or explaining what an API is?
Very simply, API, I think it was, application programmer interface is the acronym spelled out, and the particular characteristics of it that are important is that you have some kind of specified interface that sits between basically a client on one side and an implementation on the other side, two pieces of code. Mm-hmm. The interface itself has a specification. In the case of an API, in the Java sense, that's basically the Java doc.
So do you consider the only, well, okay, that's a good point. Is the API the code that represents the interface, or is it the documentation that describes the code?
It's not the running code. It's the particular Java doc that's decorating those particular elements. So right. I think of it this way, and is that it's really what you're doing when you specify an interface is you're painting a picture of various kinds of classes, methods, related things, a certain set of concepts that the client of the API is going to need to understand in order to be able to use that API to solve their particular problem. Right. Yep. And certainly they're going to have to be aware of the particular methods and classes, but the thing that's really important is they have to know what those methods and classes do.
The semantics
and semantics of things. What are the input parameters, output parameters? What do they mean? And also getting more into the sort of the actual the overview of how all of the pieces of the API fit together, which in the case of a regular Java API would be, package level and class level Java doc. But it's all of the same thing. It's words in the normal case that tell the client what they need to know in order to be able to use the API effectively. So some people think that an API should be specified more formally, however you do this. I don't know, protocol state machines, pre and post conditions. Do you think it's a problem that APIs are specified in plain English mostly, or is it good because the point of the API is to tell a story to the client how to use it? I think it's actually generally good that they're written in English because the most important thing is to be able to tell the client, or I should probably be more careful in things, it's the consumer of that API, the actual programmer who's going to be writing the client-side code. They are the ones that actually have to understand that what the particular API is giving them, and they're going to have to understand to use it. That's sort of the first client. Formalization in that doesn't necessarily help the human reader, where formalization of preconditions and postconditions can help is with other tools and other programs that could reason about that API. But first and foremost, the API, it has got to get its consumers, and that those are people. And
So if we do an episode about API design and APIs, why are APIs so important? I mean, obviously they are a kind of contract, but what are the challenges and the specifics about why APIs are the central piece, I guess, in your mind about defining systems?
Well, one of the things that is important about APIs is if you actually look around, APIs are absolutely everywhere. They're very, very important to us economically. They're certainly a thriving industry. We're developing more APIs all the time, and they're actually nothing new. I mean, we've always lived in a world of computation where we have APIs or things like APIs, specs. That phenomenon has always been with us, and so the question that I was sort of interested in exploring is, well, what is it about them that makes them so important? Yeah. And I believe at the heart of it, the fundamental reason that they're so important to us is that they're a way that we can, as humans, the programmers who are building the system, we can deal with the fact that we need to build an arbitrarily complicated system, but we actually have to deal with the fact that as programmers, we have limited capabilities as humans, right? Yeah. We can't remember absolutely an infinite amount of data. We have to do some kind of chunking. And what's happening with APIs, abstractions, all the things that are sort of in that camp are mechanisms that we use and always have used for breaking down the program into sort of mind-sized pieces so that we can actually tackle them either as individual humans or as actual teams of people who are working and building these systems. And the thing that's striking about it is we've never found any other way that we can approach problems essentially on a large scale, building systems on a large scale, without doing this kind of basic divide and conquer, where we cut up the program into pieces that we can actually we can deal with. And it's striking also that the techniques that we use really scale linearly in the size of the actual program. So a gigantic program like the Windows XP in a couple of years back, the size of that code base was estimated at about 40 million lines of code. And that, if you could read 1,000 lines a day, it would take 120 years for one person to actually read a program that size. But obviously, we don't have to understand the program end to end to be able to reason about its properties. It has seams, partitions, and various kinds of levels going on inside it. And that kind of chunking is absolutely essential, and it's what it allows us to actually understand these big systems.
So in some sense, an API is the way to express a certain abstraction in a programming language.
Yes, and particularly the API is a way to express
from the perspective of the user.
That's right. To the actual client. It's generally a client-facing contract. Yeah.
So what's the challenge to developers when working with APIs from the perspective of defining it and also from the perspective of using it? I guess defining it is the bigger struggle, because using it, I mean, you just have to live with what you get, right?
Defining it is definitely the bigger struggle. I was actually I was interested in sort of enumerating a number of different struggles that we have, because these APIs they're not easy for us. I mean, we have lots of them, so we can basically deal with them. But there are all sorts of struggles. And so one of the things that I wanted to basically do is sort of, particularly in the presentation which I did today, I wanted to actually start a conversation about what exactly is going on behind this very obvious phenomenon. And one conjecture that I have is that although we all think of this as being a completely obvious phenomenon, I think that there are differences amongst us as to how we understand that phenomenon, and that we don't all share exactly the same understanding of what we all considered obvious. And of course, one of the problems with things that are obvious is that our language rules make it rude to talk about obvious things. Right? You know, it's so obvious. Why would we talk about this? Everybody knows it. But I think there's actually underneath it, there's some different understandings of what is actually going on and the relative importance of those factors. And I think APIs is a way of sort of drawing attention to there's some very interesting things that are going on.
So what distinguishes a good API from a bad API?
I think in the first instance, I would have to, if I was going to judge an API, it's how well does it meet the needs of the consumers of that API, right? Yeah. What kind of problems does it solve for them? How large a class of clients does it support? How easy does it make those clients sort of possible to be written and expressed in a way that the people who are writing it can understand it, right? So in some sense, it's the two things that you want on the table is here's the API that I'm using, and here's the code that I'm writing to solve my problem in terms of that API. Those are the things that the programmer has to have on the table, and you want to judge the API as, does it enable someone to actually write that program, and when they look at this program, is it essentially a program that they can understand? And I think secondary consideration, also important, is the kinds of room to breathe that it allows for what goes on behind the API in terms of different ways, flexibility in terms of implementing it. Usually an API will necessarily focus on certain things that are important to the particular clients, the consumer of the API. It'll give them a convenient abstraction to work with and hide a lot of details, and often in complicated systems, there's an awful lot of mechanism that goes on behind the scene that it's simpler if you can find a way to insulate the client from that, so that they never have to know the details.
So who should design the API actually? Is it more the implementer of the functionality, who is then obviously biased to define the API in a way that is kind of influenced by the way he built it? Or is it better if the user, the client, builds or strongly influences the API because they have the scenarios in mind that govern how the API is going to be used?
It's somewhere in the middle. It's walking this very fine line. To design a good API, you want to design it for the clients. You want to hear what clients are going to do. You have to be aware of how it's going to be implemented in the kind of room that you have to implement it. But you don't want to be too unduly biased by either side, right? Clients tend, if you had to say sort of as a class, clients will tend to push their problem when they have a specific problem they're trying to solve. They will try to tend to push that into the API itself. And likewise, an implementer is more likely to expose some part of the mechanism underneath that they think is particularly significant or important, but a good API designer may be actually able to go in and sort of say, look, I can explain what's going on to the satisfaction of the clients without having to reveal those details. So it really is, as I titled the talk, APIs drawing a line in the sand. It is this line, and the best person to do that is someone who can actually walk the line, decide where that line is going to be, and then play both sides to actually sort of argue with the clients that they're giving them enough functionality to solve their problem, and to argue with the implementers that they're exposing just the right amount of information to make a client happy and leaving lots of breathing room on the other side.
If you have several scenarios that access the same module, do you think it's better to have one API that can ideally cater for all those different scenarios, or is it better to have several APIs so that the code for each of the clients that might do different things is kind of optimally readable and optimally understandable?
I don't know whether I could give a definitive answer one way or another on that kind of thing. The difficulty with having multiple essentially multiple APIs backed on a sort of common implementation is you have to actually make the story seamless to both of the parties. And the analogy I used is an API is like a cover story in a spy novel, where you actually, what you do is you come up with this story that discloses sufficient details, it's plausible, self-consistent, and enough to stop the people who are asking you deeper questions, and essentially a way to hide the actual truth of what's going on. And I think a good API is indeed trying to hide a lot of the truth of what will go in behind the scenes. And the problem when you have two APIs backed on a common thing is you have to actually make the world seem coherent to both parties. And particularly if you have data or something that could be created by a party on one side, but then accessed the party on the other side, that means you actually have to,
at least,
it has to be plausible on both things. It's easier in situations where you're say reading and writing it through one API, but only reading it through some of the other APIs. Those ones tend to be easier to get a variety, and ones where both of them they have different stories and they're both able to read and write, then it becomes more of a challenge to come up with a story that keeps them in sync.
So one thing that seems to be a recurring issue in our industry is that we work with all kinds of things, just to name a few: components, architecture, patterns, and maybe APIs, which play an important role in our daily work, but our tools and our languages aren't really able to express them as first-class citizens. I mean, an API in Java is basically an interface and documentation. Is there any way to maybe improve tooling so that it can do stuff for you that is specific to APIs?
Yes.
And what would that be?
Definitely. The tools can help. I mean, the example I think of it in the early days of text editors, knew nothing about the actual language that was being sort of written in the file. Later, we actually had syntax coloring, things which were starting to be aware of the syntax of the language. Nowadays, we're all quite comfortable with having refactoring browsers that know about the semantics of the language and allow the actual programmer to make transformations, and it can help to preserve the actual meaning of the program. If the tools know where those APIs are, they can be more sensitive and tailor their particular actions in the presence of the API. So, for example, a refactoring tool who knows where the APIs are won't, for example, propose or won't have to propose refactorings that cross the API boundary, or it could warn the client specially of it. Or an example is in the Eclipse PDE, the plugin development environment. One of the things that was added in a recent release is lets the programmer map out where the APIs are. And there's a tool which now runs as part of the nightly builds, which actually compares the API to a previous baseline and notices any signature changes, new methods coming in, and can print a report for the actual developers, and can even classify a particular change that it sees as being a particularly or potentially breaking change, like deleting a public method on an API class.
And how do you mark up the APIs? Is it annotations, or how do you do it?
It's a good question. I don't know the answer to that. So I believe it's a combination of information that's in something that's like annotations, but I don't believe it's using the syntax of the actual annotation processing facility in Java, because part of the Eclipse code base is actually earlier than the annotations, which only came in Java 5. But it's that kind of information allows a tool to be sensitive to where the APIs are, and once it knows that, it can actually help. And one day, I hope to see the refactoring engine in Eclipse also be
Be
aware of the APIs so that it can actually do better there.
One underlying assumption that we've had, but we didn't actually explicitly mention it, is that, of course, one important characteristic of APIs is that they are stable over time, or at least backward compatible. Can you talk a little bit about that?
Well, that's anybody who has APIs, that's always a very important issue in terms of how they're going to keep APIs stable. I mean, by their nature, the best APIs are the ones that don't change, right? That allows the clients who have actually written their programs against a particular API. It allows that code to keep running without actually having to be changed. That's very important, and that kind of stability is important. There's a certain kinds of evolution that you can do. Particularly in Java, there's certain kinds of things like generally adding methods, even public methods to API classes. Things are kinds of changes that can be done that don't actually violate compatibility with existing clients, either the ones that haven't been written or actually existing ones that have been compiled.
Right. So this is actually
in
binary versus
compatibility.
Textual.
And there's a host of things that you can do to the APIs that won't break compatibility. And so that's the good news. It helps to understand in advance of designing a Java API, understand Java's very specific rules for the binary compatibility and know what you can get away with. Because it's actually a very sort of tricky technical thing, because it depends on it's not intuitive at all, and it depends on the details of how the compiler transforms source code into the bytecodes, and that is pretty arcane and is not what a normal Java programmer knows or has any need to know about what the details are. And so one of the documents which I had produced going back several years now, available on the Eclipse website, is a guide to evolving Java APIs in terms of what kinds of things you can do that don't break compatibility, or when you do break compatibility, which kinds of clients you'll be breaking them with, and why they're being broken.
If you have to break the API compatibility, then one pattern I see in Eclipse over and over again is that there is actually a new API, typically called blah 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 2, which is explicitly different, and clients have to explicitly change the API they use, so you avoid the accidental kind of crash.
Exactly, and that's when we've done that, and we're not the only platform that does that kind of, uses that particular kind of pattern. It's a way the old class still remains in play, and if your program is written against the old class, you get exactly the same semantics that you were guaranteed in this earlier incarnation. And so this is a way of adding the additional methods. Is the typical thing that happens. Add additional methods at a later point without breaking compatibility. I should point out that part of those problems are, I would describe as self-inflicted, in that in the early days of the Eclipse platform, when a number of these APIs that you're probably referring to, with these numbers on them, those, you get particular fragility if you use Java interfaces. And particularly it's an interface, if you have an interface that you expect the client side to implement, then either adding or deleting methods is a breaking change. So you really are locked in. You actually do much better in a lot of cases to have abstract classes. And there's actually a very good chapter early on in Joshua Bloch's book on effective Java that talks exactly about this, choice between using a Java interface and using a Java abstract class to do these kinds of things. And they're It's important to know that, because if you make the right choice, you'll have certain maneuvering room down the road.
Yeah. On the other hand, you use up Java's only inheritance link. That's the disadvantage.
You use up the inheritance link. Yes, nothing's for free.
Sure.
Yeah. Things. So there is a general sense in which, with working within the rules of what you can get away with with the Java language semantics, you can actually do a fair amount in terms of evolving an API, but it's in a very irregular set of rules, and you're much better off studying those rules in advance and looking at the various choices to see, if you think you may need to add a method down the road to do something that you can't anticipate right now, you may want to actually make certain choices between classes and things, or also whether you have a callback style interface or whether it just is a straight call-in interface also makes a difference as to who's implementing what, and therefore what changes are breaking changes.
If I would say that every good API has to be accompanied by a unit test or a set of unit tests that verifies the semantics, would you agree?
Absolutely. The most radical version that I would seriously propose, is in designing an API, you're writing this cover story for the clients. The cover story is going to be told in the particular class and method signatures for the public methods and their Java.doc comments. And that's where I would actually begin, writing that, tell that story in the actual methods. And then, once you've told that story, then start writing the unit tests against, essentially doing black box testing against the particular APIs which you now have specified. And having the API in place tells you exactly what tests you're going to actually have to write. It also tells you the information that you're going to need to be able to implement the API in terms of what's the observable behavior that the client is going to be able to see, and therefore the things that are going to be important that the implementation gets right. All of that follows from having the API spec in place. And so the methodology that I advocate and that we try to use in the Eclipse project and the Jazz projects is what we call API first. Based, take off on the test first approach, where we actually write the API specifications and design the APIs in advance of doing the actual implementation work. And one of the things which is, I don't know whether people would find it surprising. I don't know how many people actually have tried that kind of sort of extreme, let's just write the spec, write the story of how the thing is going to work, and do that before worrying about anything else.
Well, I would say generally most programmers are somewhat wired differently, right? They want to write real code, which is the implementation, and not write prose text that explains what the code does.
Yes.
It has got a bit out of fashion, I guess.
I think that is, that's what I think a lot of people's reaction would be, that somehow writing these comments and everything it is not much like programming. And I have done this quite extensively, and one of the things that's actually quite striking is that it's very much like programming. Even though you're not actually writing the code, you still are using the same skills that you have as a programmer, because you're imagining this world, certain abstractions described this way. Here's the method. You're supposed to call this, passing these arguments. We're going to compute you this result, everything. And you can write that specification. And as long as you're not too far from home, right, in terms of you're comfortable with all the mechanisms that you would be under there, there's not really a whole lot of risk that you would write a clean specification like this and not actually be able to implement it. And so when you realize that and you write the specification, it's like, well, that's not going to take me very long to implement that thing. It's like a couple of pages of code or a couple of lines of code. In some case, you quickly say, well, let's move on to the next method and specify that. And you're building this interlocking piece pieces which build up this story. And although you're doing it much more like a storyteller and you're writing this prose text, it actually has many of the same characteristics that you have of programming and uses many of the same skills that you have to have in order to be able to program. So it works amazingly well, and it also feels like programming in a strange sort of way, even though, haven't written any line of code other than, throws new illegal argument exception or throws new not implement runtime error not implemented yet, right? That's the only piece of code that actually is in there. And likewise, when you actually have done that a specification like that, you actually have a very good idea of, you understand the API, you understand the story. You're now in a really good position to actually write clients, example clients. It's like, how would a client do this? Well, I know I've provided mechanisms like that. So you can actually write those clients. You can certainly write the tests suites, which are generally, coming from the client side as well. Sure. So you can write those. And then in a lot of cases, it feels more like filling in the implementation is the way I would describe it. It's not a major challenge because, in fact, in working out the details of the specification, making the decisions there at that level, you've actually decided much of how the thing's going to actually hang together.
In some sense, you're kind of advocating test-driven development, or seeing it the other way around. Many people say that test-driven development helps you build good APIs, and you just kind of explained why.
Yes. The only sort of issue I have with the purest test-driven development is that if you're in the test-driven development, you're writing the code and you're writing the tests that test that code. But what you're actually not writing in the pure things is the story.
I agree. Yes,
and you don't actually write down that specification. And so where you end up is in a good place in one regard, in that you've got the program, it does what you want it to do, and you've got actually a set of test suites that actually verify that the program does what it wants to do. Both of those are really, really great assets. What you don't have is an actual story that you can tell the clients.
Sure, but you could do that afterwards. Playing devil's advocate. Yes,
you could do that afterwards, but I would actually suggest that you'll get even better results if you do it first.
I don't disagree.
Then you actually go in and say, look, the first and foremost, the most important thing is what this API is going to feel like to its consumers, and make that your primary focus. Write the API specs. Then tests and implementation will follow naturally from that. And in the end, if you follow that way of doing it, not only do you end up with the program that does what you want, the test suites that test what you want, but you've got the spec, which is what the clients, the consumers need in order to be able to use the API. So you get all three of them out of the same process. Earlier, I had mentioned that I wanted to start this dialogue with developers about how they understood APIs and essentially what they thought was going on in something that all of us believe to be obvious. And I'm trying to sort of challenge people to think that there may be actual personal differences going on amongst us that we're not talking about, but actually have a big bearing. So the question, I think, is
what you're saying basically is that different people have different kind of personalities and characteristics, and they look different at the problem of API design.
Yes, I've noticed sort of quite marked difference in essentially all of the people that I've worked with sort of over the years, both at IBM and in former lives. I've always seen a wide variety of practices and sort of views of the things, although it's very, very subtle. So one of the things that feels very important to me is that as programmers, we actually have this interest. I mean, we get paid as professional programmers to build systems that do things, right? That's the heart of programming, right? It's a very active process. that engages us mentally, and the thing that we're building is something which actually physically does something, or at least information processing wise. And so we have this bias, I think very strong bias for action, for doing things, and that side of programming. That's what has attracted many of us to the programming profession. That's what's selected. That's why our employers have selected us, or our college programs, is because we became fascinated at a relatively early age, in most cases, most of us, with this mechanism and being able to control it and make it do what we wanted it to do. And that is a very, I believe, very important property that we have and we share as programmers, but I think we share them to different degrees. And part of the way I look at it is there are certain kinds of tasks, programming tasks, which we can all relate to, that sort of elicit somewhat of a fairly visceral, gut level reaction as to how we would approach it. So if I told you, there's this database that's over here, it's got certain data in it, you're going to have to use this, wonky API that, here in order to be able to get at it. I know you're not familiar with it, but you're going to have to actually use that. I'm sorry. And I need certain data taken out, analyzed. I need a report, and I need it tomorrow. Right? And I put you in this particular situation and ask how you would go about doing it. And the kinds of things that you probably wouldn't even give a second's thought in the way I had framed the problem is you wouldn't think about carefully reading API documentation or handling rare conditions or writing test suites or any of that. You'd probably just jump to, I'm going to wing it. I'm going to go in there. I can be in the machine with the machine. I can start building this thing. I can actually start Googling for
examples,
snippets that use the API, steal, take other people's programs, examples and things like that, and mutate them till they work, debug them and things like that, and really just live in the moment with the actual program. And that particular aspect is, I think, something which we all share to some extent. A lot of people make this as essentially a recreational programming. I know people who go home at night and do exactly that kind of thing for that kind of sort of thrill. But it's also striking that when you look at how that kind of programming, how it relates to what we do day to day as professional programmers, writing in industrial sort of commercial software, there's actually, it's related, but it's really quite different. And the kinds of things that are really important to us on a day-to-day basis are familiar with us. We have to deal with the fact that we're writing a program here, but it's going to run somewhere else on somebody else's machine, and it has to make sense in their world. So there's this disconnection between where we're writing and testing it and where it's really got to work. So we have to pay attention to a lot more stuff than we did in this other kind of thing. The program is getting much bigger than something that can be written in a day, and that's really important. The program's going to live much longer. It's actually going to take a team of people working together to actually build this thing. It's not just a sort of one lone wolf programmer at night. And all of these kinds of things are essentially different contexts for the programming. The particular thing that's striking is that kind of guerrilla programming skill where you actually go right in there really goes for this mechanistic side of computation, right? The part of computation that has to do things, but the whole side of computing systems having to do with APIs and the scrutability of how we break down a large system into pieces that we can get our heads around, that side of things isn't addressed by that mechanistic side of things.
It requires more conceptual thinking.
And what we're doing as programmers is we're actually playing this double game, right? We're definitely going for the mechanistic thing. We have to build something that does things, but we also have to keep all these other factors in mind, including we have to build a system that we can actually understand, that multiple people on the team can actually share. It can be evolved over a long period of time. All of that kind of stuff has to be done. And the things that have to do with the scrutability of the program and how we understand it are essentially not the mechanistic properties. And so one common failure mode I've seen many times, I would describe as a programmer has gone over to the dark side because they've I believe got caught up with the mechanistic side of programming, and it has been such a powerful force psychically in terms of their things that they've actually forgotten some of the other things because they were just completely sucked into, hey, make this sucker work. And I think that that's a really important thing to realize about ourselves, that we have this draw to the mechanism, but usually there's more than the mechanism that's important to us, and we have to make sure that we train the programmers to understand how to sort of modulate that world and to do the right things at the right time.
It's maybe also a call for changing some of the curriculums in schools to maybe take that into account a little bit more explicitly.
Perhaps
because
that's actually
programmers know about this stuff, and newbies often don't.
Yes, I mean, I think very much the kind of I think of the hackers working on viruses as not worrying too much about anything other than the mechanistic side of things. They really are in there for the let's make this system do something. But yes, but I think even with the training and everything, it's important to realize that not all programmers have the same degree of urges, and
so give everybody the task they're good at.
That is actually one very smart thing to do. Is that if you have someone who seems to be drawn very much to the mechanism, they're probably not going to be very good at defining APIs because that's going to be sort of antithetical.
And that is something I notice quite a lot in the modeling environment, where I carefully look at the people who will do the meta stuff, right? Meta models, transformations between models, because thinking meta is different from people who have more this mechanistic view. I think that's a kind of similar problem.
I believe it's the same thing going on there. That there's certain kinds of things that we're really good at and drawn to, but there's also a bunch of other skills that we need in order to be able to build these complicated systems.
Okay, we have to wrap this thing up for timing reasons. Is there anything else you want to briefly say to leave our listeners with?
I would actually leave them just with a challenge to actually look at their particular practices, either personal programming practices or practices in their organization, starting with their small team, and see whether there are things about their work habits, the methodologies that they're using, that are essentially either pandering to the mechanistic side, in particular pandering to the mechanistic side to the detriment of the non-mechanistic side, right? They're ignoring the APIs, ignoring the extra testing and things like that, and just going for the thing. I think our built-in natural biases in the field give us it's almost like there's a certain force of gravity that will be drawn to it, and that any kind of thing which causes people to actually look at what they're doing and reflecting, is this really getting us where we need to go fastest? I think that's a good thing to do.
Not very nice closing comment. So thank you very much, Jim, for being on the show.
Thank you, Marcus. I've enjoyed this interview very much.
Good. Great. Thanks. Bye.
Bye-bye.
Thanks for listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig Reddit Delicious links and the /dot button. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.